Hi guys, let's talk about states of matter. Some of this will be review for you. A little bit of it will be new, but most of it will be review. So our three states of matter are solids, liquids, and gases. So let's start with a little particle diagram to show what these solids, liquids, and gases are. So we're going to start with solids, and I'm going to draw my particles. Now, I'm not very good at drawing. So, if you're drawing this, hopefully you are better at drawing than I am. Try to make all your circles the same size. And I'm also going to try to make them kind of neat with rows and columns. Again, my drawing is not that great. I try, but hopefully yours is a little bit better. But the key is that solids are close to each other, and they're in this nice crystal that is really ordered. Gases are kind of the opposite. They are really spread apart, and they're really random. Oh, let me draw. Let's see if I can. I'm going to do it a different color here. That way we kind of distinguish between them. So let me go with color. Let's do blue. So there we go. And for liquids, let's go with a different color. Let's go with green. For liquids, a lot of people think that liquids kind of look like they're in between solids and gases. That's actually not true. Liquids are very similar to solids. So the spacing between the particles is almost the same as it is in solids. The main difference is that in a solid, these particles are ordered in this nice like pattern, whereas liquids are kind of random. So I'm going to try to draw these as best as I can. So I'm going to draw them pretty much the same spacing between them as the solids, but just more random, like that. Okay, let's talk about some properties. So let's talk about the placement first. So here the particles close together, but they are randomly arranged. Here particles are far apart, also randomly arranged. And here particles are close together, but they're in this nice ordered crystal. So very high ordered arrangement. All right, let's talk about the movement of the particles. So in a solid, the particles are moving, but they are kind of stuck in their place, and so they vibrate in place. So an analogy to this, imagine that you guys are particles and you're sitting in the classroom in chairs, and we put the chairs kind of close to each other, but the chairs are ordered in these rows and columns. And so you're close to each other, you're in this nice orderly pattern, but let's say I tape you to your chairs. So you're still able to move your arms around, you're able to move your legs around, but you're not able to get up and move around each other. And so same thing with solids here, they're able to move around, but they're stuck in their spot. So they're vibrating in their place. And because of that, that's why solids retain their own shape. So I'm going to say retain shape. Or maybe I'm going to say, okay, let's see if I can erase it here. I'm going to say have definite shape. Definite shape. Also, because they're so close to each other, already condensed, they have a definite volume. So now let's look at liquids. So liquids are able to slide around each other. So particles slide past each other. So in the analogy where you guys are particles, it would be like, let's say we have a dance party. So you guys are still close to each other, but now you are kind of moving randomly, and you are able to slide around each other and change your position when you are dancing. And so the particles can slide around each other, and because they are able to slide around each other like that, they're not stuck in their spot, they are able to take the shape of the container. Again, as opposed to the solids stuck in their place, and so they have their definite shape. Because they are condensed together already, we can't really change the spacing between them very much, and so they have a definite volume as well. So they do not take the volume of the container. Now let's look at gases. Gases go crazy. They are rapidly, let's say rapid and random motion. So the analogy here would be if you guys were gas particles, imagine you go to an amusement park and you ride bumper cars. If you are in your car, you are going fast, you are going randomly, you hit each other, you hit the walls. That's what gases do. They move very fast, they move very randomly, they're hitting each other all the time, they're hitting the walls of the container, and so they're going crazy. Now, because they are able to spread apart like that, and they're moving randomly, they can take the shape of the container. And also because they are spreading apart, they can take the volume of the container as well. And because of that, gases are compressible. If you grill at home using a gas grill, you use propane as your fuel. Propane is a gas, but they compress it into cylinders, into a small cylinder. So they compress it because the gas particles have really large spaces between them. So we're able to get them close to each other and compress it. Solids are already very condensed, and so these are non-compressible. And for liquids, they're almost non-compressible. They're pretty close to each other. There are a few liquids that you are able to compress a tiny bit, but it's almost negligible. So we're going to say almost non-compressible. Okay. Another difference between these three is the density. So we know gases, like let's say you have the same amount of particles in all of these, so they have the same mass. Gases take a huge volume because they're so far apart, and so they are by far the least dense of the states of matter. There we go. Solids are usually the most dense. Because their particles are the most compressed together. And liquids are usually slightly less dense than solids. So the density of the liquid and the solid are very close to each other because you can see from my particle diagrams here, the spacing between the particles in solids and in liquids is very similar, and so their densities are very similar. And both of them are way more dense than a gas is because the spacing, the volume of gas particles, or the volume between gas particles is huge, right? So these by far are the least dense. Again, these two, the solids and the liquids, are very similar in density. Usually, the solids are just a tiny, tiny bit closer than the liquids are, and so they're usually just a tiny, tiny bit more dense than the liquids. The liquids are slightly less dense than the solids. That's true for most substances, but the reason why I say usually is because of water, right? Water is the opposite. Liquid water is more dense than solid water. So if you take a cup of water and you put an ice cube in it, the ice floats. The ice is actually less dense than the liquid. That's not normal. Water is very, very unusual in that. All other substances, it's the opposite. The solid is more dense. So for example, if you've ever made candles, melted wax, if you melt wax and it's a liquid, and then you take a chunk of solid wax and put it in, it's going to sink to the bottom. So most substances are like wax. That's the normal thing, that the solid is just a slightly bit more dense than the liquid. But again, they're pretty similar. Another difference is that liquids flow. They also slowly diffuse. Gases flow and diffuse, and they diffuse much faster than liquids do. And then solids do not flow or diffuse. Now, what is the difference between flow and diffusion? Flowing is when the movement is in a certain direction. So usually like the rivers will flow, usually based on gravity, right? They'll go in one direction, not the other. So flowing has a certain direction. Whereas diffusion is random. So diffusion is when you have gas particles move through air or move through another gas randomly. So if I spray some perfume in the middle of the room, it's not going to go straight down. It's not going to go in a certain direction. It's going to diffuse throughout the whole room. So eventually the whole room will smell like that perfume. Same thing if you light a scented candle. That scent will go everywhere. It's not going to be just like downward where gravity is. If I open up or I peel an orange, I'm going to smell it everywhere in the room. And so that's diffusion. So gases diffuse, liquids very slowly diffuse. If I were to take a cup or a graduated cylinder filled with water and I add a drop of food coloring, you can try it at home. It doesn't actually go straight down because of gravity. It actually diffuses. It goes to the sides as well and up. It goes randomly in all directions. And so they do diffuse, but very slowly compared to the gases. Solids, they do not flow and they do not diffuse. The last thing we're going to talk about in terms of solids, liquids, and gases is the energy. There we go. So these, in terms of energy, and I'm just going to draw an arrow showing the energy going this way. So there are two types of energy that we usually talk about. Kinetic energy has to do with motion. And so the faster the particles are moving, the more kinetic energy they have. And so typically, gases have the most kinetic energy because they are moving very fast. Solids have the least kinetic energy because they're moving very slow. They're just vibrating in place. The other type of energy is potential energy. Potential energy has to do with position. And typically, the farther the particles are, the more potential energy they have. Kind of like if you climb up on a mountain and you're high, far away from the earth, because the earth is attracting you, right? So you'd have high potential energy on top of a mountain compared to low potential energy if you're flat on the ground. The farther away you are from whatever's attracting you, the more positional or potential energy you would have. And so gas particles, or any particles, really attract each other. Any two things that have mass will attract each other, right? And so if they are far apart, then you need more potential energy. So they have more potential energy. Whereas if they're close to each other, then they have less potential energy. So in terms of energy, gases have the most potential and kinetic energy. Solids have the least. All right, let's talk next about changes in state. And again, most of this should be a review for you. Again, in terms of energy, I am increasing my energy. I'm going to draw it again this way. So gases have the most energy. Solids have the least energy. Now, liquids, notice, are not exactly in the middle, right? They are a little bit closer to the solids than they are to the gases. That's because both the motion and the position of liquid particles are more similar to the solids than they are to the gases. Gases are drastically different from solids and liquids. Let's review the different phase changes. So as we go from solid to liquid, that would be called melting. Going the other way is called freezing. Another name for freezing is solidification. Don't feel like you have to know that. You can choose either word. Melting, another word for it is fusion. Again, you do not need to know both. Just pick one, melting or fusion. Going from liquid to gas, that is vaporization or evaporation. Again, you can just pick one of them. You don't have to know both. Going from gas to liquid is condensation. And then the two that people always forget, going from solid directly to gas without stopping in the middle for a liquid, like dry ice. Hopefully you've all seen dry ice. If you haven't, when we're at school, hopefully I can show you some dry ice. It's really cool. My 3-year-old loves playing with it. That is called sublimation. And then the last phase change is going directly from gas to solid. That is called deposition, like depositing. All right, that's it for the states of matter. Have a great day.